Hello, Matthews Gatos here. In this lesson, we will look at parity of a function. So parity of a function just means, is a function even or odd? So let's start with even. If the domain of a function centered at the origin, such that f of negative x equals f of x for all values of x, then we can say that f of x is an even function. Let's break that down. Okay, so f of x here is just my original function. And we're saying that that original function is equal to f of negative x, which if you remember to transformations just means b is negative 1. Now if b is negative 1, I have a horizontal reflection in the y-axis. So in other words, if I have a graph, and if I reflect it in the y-axis and I end up with the same graph, I can therefore say the function is even. So f of negative x equals to f of x, then y equals to f of x is symmetrical about the y-axis. That makes it an even function. So here's an example. This quadratic, the domain, the middle of the domain, is centered right at the origin here. So if I look at, for example, this side of the graph, if I look at that side of the graph and I reflect that side of the graph in the y-axis, I end up with this side of the graph, and vice versa. If I have this side of the graph and I reflect it in the y-axis, I get this side. So I can say that this quadratic is an even function. Over here, this is an absolute value function. So if I look at either side of the function, for example, let's look at this side here, and I were to reflect that in the y-axis, I end up with that side there. And vice versa, this side reflected in the y-axis gives me this. So I know that these are both examples of even functions. Let's look at odd functions. So again, the domain of the function is centered at the origin. If we have f of negative x equals negative f of x for all values of x, then I can say that f of x is an odd function. In other words, if we take a function that has been reflected in the y-axis and it is the same as the function reflected in the x-axis, I can say that those are odd. They are symmetrical about both. So if I have a graph f of x that is symmetrical about the x-axis and the y-axis, or another way of saying that is symmetrical about the origin, then I can call my function odd. So let's look at an example here. So this is centered, the domain of this graph is centered right at the origin. So I can take any piece. For example, if I take this piece here, if I were to reflect this in the x-axis, I would get that piece, and then take that and reflect it in the y-axis, I get that piece. Vice versa, I could take this piece reflected in the y-axis, reflected in the x-axis, and I get the other half. So I know this is an odd function. If I look at this graph here, this is the domain is centered at the origin. So if I take this part of the graph here, and let's say I reflect it in the y-axis, I would get this, and then reflect it in the x-axis, and I get that. I could also take this piece, reflect in the x to get this piece, reflect in the y. So I can see that this function is odd. Now the only function that is even and odd at the same time is the function f of x equal to 0. So functions we can say are even or odd or neither. Let's look at this from an algebraic perspective. So algebraically, a function is even if f of negative x equals f of x. Algebraically, a function is odd if f of negative x equals negative f of x. Notice that both of these definitions start with an f of negative x. So that's going to be my very first step. Start with f of x and replace x with negative x and simplify. Then you see what you're left with. If you are left with, after simplifying f of x, then the function is even. If you're not left with f of x, factor out a negative 1. And when you factor out a negative 1, if you end up with f of x, then the function is odd. If you don't end up with f of x, then you can say it's neither. So let's determine the parity of this function f of x. So very first thing, I start with f of negative x. So replace each of my x's with negative x. And then I simplify. So negative x exponent 4, because it's an even exponent, a negative multiplied by itself an even number of times is positive. And same thing here, negative x squared, a negative times a negative twice is just a positive. So I just check, and this is f of x. So since f of negative x equals f of x, I can therefore say that f of x is equal to an even function. Let's just check that graphically. You can see here in y1, I put f of x. So this is the graph of f of x. And then you can see in y2, I put the graph of f of negative x. This is the graph of f of negative x. You can see comparing those two graphs that they are in fact equal. So that tells me that yes, it is an even function. Okay, let's do the next one. So I want to determine the parity of g of x equals x cubed minus x. So the very first place I start is with g of negative x. So replace each of the x's with negative x. Step 2, simplify. So a negative raised to an odd exponent is negative, because a negative multiplied by itself 3 times is still negative. If I subtract a negative x, that's the same as adding an x. So the first thing I check is this g of x? And it is not. So step number 3, I factor out a negative 1. So negative x cubed divided by negative 1 is x cubed. X divided by negative 1 is negative x. And this, I check to see, is that equal to g of x? And it is. So I know that g of negative x is negative g of x. So since that is true, I can say that g of x is an odd function. Let's check this on our calculator. So on our calculator, I put in f of x into y1. So you can see this is the graph of f of x. And in y2, I put the graph of negative f of negative x. So this is the graph of negative f of negative x. And you can see those graphs are the same. They are equal. So that tells me that f of x is in fact an odd function. Okay, so just to summarize here, if I reflect upon, if graphs are symmetrical upon the y-axis, they are even. If they are symmetrical about the origin, in other words, x and y-axis, they are odd. And by odd, I don't just mean strange, I mean symmetrical about the origin. So to practice this a little bit further, you guys can do textbook questions number 1 and 2. Hope this helped.